You are muted, I think.
Okay, now, thank you for that. We will continue. Now that we know, so I was saying that our files are okay. In case you get disconnected and you don't see a number here, for example, in your Colab, rerun the cells and it will be fine. Now what we're going to do, we are going to see if we can use, for example, like a previous checkpoint to like a checkpoint from pre-trained, for example. I will give you I will share a file with you to see if we can generate this. So we will do a couple of things first. I will go to, let me just share a file. I will share a Dropbox file for you, and that will be the one second. Copy Dropbox link. Should have done this before, but okay, it's already there. So let me open the chat. Now where's the chat? Just 1 second again. Oh, here it is. Okay, the chat. Please download this file. Okay, 1 second. I'm having a technical problem here. Somewhere here. Now, download this file. This is just a random train file from Runway. So this is a PKL file. Download this file to your Google Drive, to like in a specific location of your Google Drive. So for example, download this to you can create, for example, like a folder with for checkpoints. I think I have one. Yeah, for example, here I have one that is called the StyleGan checkpoints, and I have a couple of things that were already trained. So basically, you know that there is a path on your Google Drive to use for this. So download the file, copy it to, or download it to your Google Drive so we can use it. There is another way that you can use it directly here. So like directly with the link that I just provided, I think it should work. So let's say you want to copy paste, you copy paste the link that I just gave you. If you do this following trick, if you change, you see that here it ends with a DL equals 0. If you change this to raw equals 1, you will have direct access to the file. So for example, if I do this, it opens the actual file. And this is quite interesting because you see here, you see the information of the file. Here it tells you, it has the architecture. It has like functions, it has like a lot of information, and then it's just like gibberish, because basically here it has information about the weights. This is like, of course, like an encoded file that is opening. It's like 300 megabytes. But if you do this, what I just did, basically like replacing, I'm commenting this in case you have problems uploading because your connection is not fast enough. You can change the DL equals 0 for raw equals 1, so we can use this in our code. But I will follow this path that I have here. So do I have it somewhere here? Probably not. Let me actually, I will upload my file. So one way to do it here in Colab is that if you say upload the file, I can go to my actually Google Drive. Drive.google.com, StyleGan checkpoints. And here I will just drag my file. It's going super fast. I'm running out of storage. So you see the file is here. So now if I refresh this, I should see the famous file. Yeah, here it is. So you see, I just copied, pasted, and that's good because I'm going to use this. So now that we know that we have a file, a PKL file, I will give you more alternatives, like for example, like the faces and others that you can use. We will navigate, we will generate data using our GAN. So this is like the step 3. Step 3, navigating latent space of our pre-trained model. Because we need to understand a couple of things that we can do. So I will do the following thing. We want to execute because the code is already here. We have our code for GANs. We have it here. So we want to use a specific file that is the generate.py. This is already a Python file. How do we execute inside Colab a Python file? Doing the same trick, basically using terminal commands. And by that, I mean, you click the exclamation mark, and we write Python. And then we do the following thing. I mean, you can write it manually, but in this case, just to save a couple of minutes, we can just right click in the file, generate, copy path, paste it. So basically, right now, what this is doing, this is executing this Python file here by just indicating the path. And now we need to pass arguments. Usually when you use a Python, you call the Python file from a Python file from let's say like a terminal or a PowerShell on Windows or on Linux. You write first Python because basically that opens the Python interface, and then you give the file name, and usually those file names, if you need to pass some parameters, those are arguments, and those arguments usually you indicate those like this. So for example, I don't know, you want to generate images, and you can specify like num images equal to 1000. So that's what we're going to do now, and we need to specify in this case the network. And the network is actually the file path of our file, the one that I just sent you, or the one that I just uploaded to my drive. So in my case, for example, if I go to StyleGan checkpoints, right click, and I copy this path, I can just copy and paste this. So you see that this is pointing to the path where that file is, the PKL. An interesting thing is that this file is the one that I downloaded from Runway ML. So I didn't do the training here in Colab. We will learn how to do that next to this step. But first, we need to see if this is actually working. So we need to indicate now, because we are going to generate a couple of images following one specific, let's say, procedure to navigate our latent space. Second, to do that, we need to specify an output sorry, an out dir. Basically, this is an output directory. And that output directory could be whatever you want. So in my case, because I want to save everything here on my drive, I can just right click, create a new folder here on drive, and name it like temp output. And this temp output, now it changed location is here. Again, I can do the same thing. I can just like copy the path and just paste this. So I'm giving a different path, so it will save the images there. And the last parameter, this is the basically one of the important parameters. There is one thing that is called seeds, and seeds basically is like a number that is related to basically it's an index to generate something. So in this case, I will pass a range of numbers, so the model will know how to generate a set of images. So for example, you will understand what I'm saying right now. So if I press here, seeds equals to, let me give a range, like I don't know, like 450 to 455, it means that it will create 5 images with those IDs, like 450, 51, 52, 53, 54, 55, right? Because basically it's like this is the vector. Basically, this is pointing to a specific vector. So I will just press play, and when I press play, basically this will out there. Okay, it says that it got a extra argument. Let me try again because I had a blank space. Okay, now, so you see what this is doing. This is right now loading the network from the file that I just provided. This is, you see, this is setting up PyTorch plugin. So basically it's taking its time to load everything because this is a huge network. And it will generate images. So while we're doing this, you see this is working. We will get some images in that folder. But let me go back to understand a little bit to give a little bit of context. What do I mean with latent space? So let me go to here to Runway. If I go to MLab, latent videos. No, actually, let me go to my assets. The model that we're using is this Mary. I want to add this model to my workspace because basically here, if I add, let me just delete this and delete this. This is the current workspace. If I click on vector, this right now, it will start populating. If I run the model, this will start populating this with images from that model. So basically it will do exactly what I'm doing, and it will start creating a grid of images. And the good thing about this is that we can sample in a very easy way those images and to visualize those in case we want to generate like a specific content. So there are like a couple of, you can specify, for example, a sampling distance, meaning that you can basically transition from one specific image to the other. I hope this starts generating soon. It takes a while, but that's fine. Let's go back to our code in the meantime. So it finished generating images for seed 451 up to 456, and we see those images here. So you see, if I go to the PNG file and if I click on it, we see that this generated an image. Probably the model was not very good, but we can see that there is something there. It is actually doing something. a Frank Gehry type of building. This model was not trained for long. It was trained for 3 hours. So if you want to get better results, probably you want to train at least for 24 hours. But it makes sense. I mean, it kind of makes sense. The things that this is showing. I mean, some resemble some like Frank Gehry windows or not. So yeah, you will see that it shows like images that kind of look in a certain way.
Sorry, Diego, could you just go over the last bit of code that you did after the .pkl?
Oh yeah,
and
here
what's that bit of code doing?
So basically this, again, this is just calling the file generate. So let me go to that file generate, that py generate. So this is the file that we're actually executing. So if we go here, you see these are the arguments that we are passing to that file. So we can see that this argument here, network, basically it asks you for a PKL file. Basically, it's a network Pickle file. Then it asks you for a number range. So basically, when you generate an image, you just need to pass like a specific number. So according to that number, the network will take that number and it will generate a specific information. You have other parameters like the truncation that I don't remember specifically what it is. You have other parameters that are not necessary in this case. So for example, if you're training something that you want to generate like only people with glasses, things like that, you can do this, but it's not important for now. But what is important is basically here, this is the other parameter. This is the output directory. So basically it's a folder created to store the images. So this is why I gave this, as I created this folder and the images are here. So those two parameters, basically those three parameters are here. First, the network. Basically, you just feed a path, a file path. Then you have the output directory. It's also a path to this directory in our Google Drive. And the seeds is a range of numbers. So this is why I'm trying to here that is working right now.
And sorry, does it have to be a path that exists, or can you create like a new path and it will generate?
It's better that if it is a path that exists for the output directory, because it can give you an error, because right now we're not using something that is called the mdir or mkdir command. That is a terminal command where you can create through the terminal the code. I don't think it's embedded in the generate, so it's better if you create your folder and then just point to that path. What I want to show you here, for example, is that these are images generated from the same model, exactly the same model. Some are like Frank Gehry on ruins, like after like atomic bomb exploded. But on runway, for example, say vector to, if you right click on an image, you can get something that is called a JSON file that is going to open it in Xcode. I don't know why, but just let me check on my downloads because I want to show you the actual information of that. Just give me one small second. So basically here, if you see my screen, that vector is basically like a bunch of numbers that are fed into this network to generate a specific image. So in this case, I mean, what we are doing with the generate, we're just pointing like a random number, right, in our code that will give us these numbers. But this is for us like implicit, just as runway. We could modify our code to actually like download, like to input these numbers, but it's easier always to give a range. So you know that this will generate, I mean, it's instead of having like a list with a lot of information, a lot of shit in it, we're just inputting like one specific vector right now. That is not very so basically what we're doing with the seed number, we're generating the vector to generate our images. So you can try like whatever you want. I mean, if we give the range from 1, for example, to 10, this should generate 10 images. So again, it will go through the process of generating this. Let me give you a couple of models so you can play with them. So just give me 1 second. Because I have a couple of things that you can use and download directly from internet to generate more stuff, not only my crappy Frank Gehry model. But what I want to do, I mean, this is why I will give you like some extra options. Just give me 1 small second. I just need to find one specific thing on my files because I have like some addresses. We will do a couple of things that are interesting with this GAN, and after that we will move to our own training. Where is this thing? I have too many files, and even though I try to organize everything, sometimes I get this one. Let me know if this works. I mean, the code, as you can see, is like it's basically nothing. It's nothing because it's simple. Let me see, because in my other screen I have like a lot of things. Where is this? We should have it somewhere here. Just 1 more second. Probably here I have it. No. Too many things. Here, I found it. I will copy and paste a couple of things that you can also use. So I think if I have this here. Yes. So I will give you some PKL files that you can use, especially one, like a typical one that you can use with that are probably like more interesting results. I will put it in the chat. If you replace the path of that file that I just gave you with one of this things. So for example, if I replace the local path of my Google Drive with what I just gave you here, mean, we can do something that is like a little bit smart. So let me just modify this code. I can say that the URL, oops, not that. Here, I can write just URL and comment this. And instead of like passing a path, let's see, two things, URL equals to this. And I can comment this. So basically, I'm just gonna pass like a simple parameter that is URL here, and that URL now I'm just using one of the models from NVIDIA. So let's see what happens now that if I change that PKL file, if it will give me, I don't know if this will give me a problem. No such file or directory. Oh yes, so I need to do one more thing. Yes, I need to do one more thing. In order to use this file, this URL, I need to do the following thing. tflib, I think this will work. Will this work? If not, we can continue working with our, no, this won't work. Okay, never mind about this. Sorry about this. I can point you to other files in a second, or actually work with, let's just work with this file. I will tell you something, because that file, I realized it's trained on the TensorFlow instead of pytorch. So it won't work unless, let me check one more thing. StyleGan2 ADA, unless they provide a specific model here. So external data repository. Oh, they have pre-trained. So maybe let me give you this. Paper data sets. Well, let's do the following thing. I will continue with because otherwise we'll waste a lot of time. Let me just give you this in the chat in case you want to use like other models you have pre-trained. The idea is that I will teach you how to train your own, so you can load these models that were trained on PyTorch to generate something, to generate other stuff. And in the bonus, I will teach you how to do this on Runway, and that's it. So don't worry about that yet. So I just wanted to show you how to generate a different thing. So it will be convenient actually if you express your model URL like this. So let me see if this works. Yeah, it needs to be a string. So if I do this, I need to put this in between quotation marks. URL, what happens? Also fetch URL. No. Okay, whatever. I don't want to waste time. I will fix it when I give you the code. I just don't want to waste time in stupid like things that we don't need to solve right now. So let me go back to the way it was. Okay, now it's loading the network. I will show you how to. I will give you a file that basically has everything here for you to use. So now again, I'm generating other type of images. So for example, because I changed the seeds, this created images, image 0, 5, 7, and so on and so forth. That's not the important thing. This was only to prove that our GAN is working here, right? An already available to use GAN. Go back to my notes a little bit to check. So now that we tested that, we want to do a couple of interesting things, and just those interesting things are related to content generation. I'm going to change my headphones because the other ones are dying. My AirPods are dying. So again, also 1 second. All right, I think now, can you hear me?
Yeah.
Yes? Okay, awesome. So now let's continue. So what we want to do is to use actually this model to create some stuff. Actually, I will teach you because the code for GAN is complicated. I mean, in the bonus, I will show you how to code like a simple GAN, so you know. But the important thing right now is how to use those, right? So we will do a couple of things that will allow us to interpolate, to do one of the most interesting things, that is that interpolation step. And this will take basically this is interesting stuff. So now we will say like step 4. Step 4 will be actually using the free train model to interpolate through the latent space. So for that, we will do a couple. We will do a couple of things in code. So first, we will do some imports, and we will import sys. So basically, this is like system functionality, because we need to do one specific thing. We need to append, basically add the repository, basically the files from our StyleGan to our system path. This is like a typical thing. If we don't do this, basically like Colab won't know how to use certain files or interact with certain things. So we will do this, have that insert. And here we want to do the following thing. Right click on pytorch, copy the path, and paste it here. So if we do this, basically we are adding the path, the routes to all the files in our repository to our system. We want to do a couple of more things. We want to import Pickle. Pickle is something that allows you to basically encode information, like large amounts of information in a Pickle file, just like I show you here in with the pre-trained model that I shared with you, but also allows you to depickle something. So it's like to encode and decode, right? It's like similar. I mean, I don't know if it's exactly the same, but it's like similar to zip files, let's say. So we want to also import OS. We want to, of course, import NumPy That is always important because everything is like related to NumPy. We want to also import PIL, that image, because we want to basically work with images. Right now, in the step 3, we just tested the data generation, but now we want to do stuff with that data, show it and transform it and interpolate, for example, and to create things that we can use, for example, inside Grasshopper. So we will do a couple of more things. We will say like from Python that way import image. What else? We need import matplotlib as PLT. Remember the matplotlib pyplot that we used yesterday to generate a specific plots of our thing. We will use that. Also, we want to import actually they should be here. Import Python, sorry, is Python.display. And from IPython display import image, then import matplotlib. Now we should import torch and import DNNLib. That's to use the deep neural network library. Let me just, people are sending me messages. And finally, we want to import, let us see, we'll explain why we want to import these things. So if we do this import, we have all the things that are necessary to start basically coding the things that are interesting for us, not the data generation or things that are already there, but we want to generate a couple of now, for example, we want to code our, let's say, helper functions that are functions that will help us work with the data that we generate. Methods to generate content. So basically, a bunch of methods to generate content. And we will start with a couple of things. How, for example, we generate a seed number to a vector. Actually, what was I show you that Rangoy was doing. So we will do that. We will generate, if you're familiar with Python, you will know what a definition or a method is. If you're not, basically it's just a set of instructions that you can call repeatedly without recoding everything, right? It's like a template that will take parameters and it will generate something. So here we will do our first. It's like transform a seed number to a vector, and we will call this to declare a function in Python. You just do def. It's a definition. We will call it seed2vec, and this will basically take two arguments. And I'm just going to write it here. So, for example, when you call this method or this definition, you will do like seed, for example, and you will have parameter 1. That could be a number, for example, and parameter 2. And those arguments will be passed inside our definition to generate something. So in this case, and let me do this, we will pass two arguments, and those arguments will be G for the generator, and the other one will be seed. So basically, we will pass the generator and the seed number, and that will return. Basically, this function will return something. It will return a NumPy random state. It will take the seed and n, and it will take like 1, and g c dimension. So basically, this will take a number and it will create that set of random values according to that vector. A little bit of like Python-ish or Python typical like syntax that is kind of I don't know, like weird sometimes. But basically, this will return something. We will plot the results to understand what we're doing with this when we execute this. We need to create also a function to generate the image, or to show the image. Sorry, to display an image, and that will be a definition. We can call it display img or display image. This will take the information of an image. So if we press like 2 points, we press enter, we are indented one space to the right. So everything that is indented to the right one space, it will be considered as code inside this definition. So to do that, this is quite simple. We will select PLT axis. We will disable the axis, so it doesn't show like the lines for X and Y, for example. We will say plt.inshow image. So here, basically what we're passing, sorry, this is image. We are passing the information, the parameter here that we're with the parameter image, and we're using that here. So it can display through PLT show the image that we want. This is just to show the image. Now, one of the main functions is actually the function that generates the image. So to do that, image function. I'm a little bit dyslexic today, so def generate image, and that will take a couple of things. It will take a G, the generator. It will take C, the vector, and also truncation PSI. So I didn't want to explain this, but probably I should. What is truncate? You always find like information. I'm always showing you how to easily like look for information. What is truncation in the StyleGan, for example? Truncation trig is a latent sampling procedure for generating samples from truncated values which fall outside a range of resampled original. I don't remember that. Train. Here, sampling and truncation. Anyway, I don't want to waste time with this. We will leave it for the part that I will. Yeah. So basically, you need the truncation parameter to generate like in a specific image. We will see that later. I don't want to waste time because we're doing very good with time. So to generate basically this, we want to render images for latents initialized from random seeds. And for that, we will do gs underscore kw args. So basically, these are parameters. We will start with this. So we will say like the output transform. Output it will be a dictionary. A dictionary basically is exactly that. It's a list that contains basically a key and an information. So this is, again, like kind of complicated syntax. It's not important, just bear with me on this. I will try to explain in the third part. But I will expand too much now to explain why we need this. But basically, bear with me. We'll say like function. Do we want to do that? Yes, we want to do this. Live, convert images to int uint 8. So basically, we need to convert our information into like image format. This is like kind of again like weird. NCHW to and HWC equals true. So we're just going through a process of transformation of data here, and also we want to randomize noise, and here we want to put this to false. We don't want to randomize the noise for the generation because we already have information from the vector, so that is okay. Here we will put in our definition if, for example, truncation PSI is not none. Basically, if we don't, if we pass this argument, this is like an optional argument. We will say this. Our generator arguments will be here I should do it like this. Truncation psi equals to truncation psi. So basically, if we pass this parameter, it will add this to like the parameters to actually generate an image. Again, that is not the important part of what I want to show here. The important part is actually what is coming next, where basically we will create something that is called a label, np dot zeros. We'll do a couple of things. So here, basically, what we're doing, we are creating. We will create now an image from the data from that vector. From basically the seed will generate this vector, this list with like with weird numbers, basically like decimal numbers, and then we will pass this into our generator to generate an image from that. So for that, basically we'll say like that label is g that input shapes. Again, this is like if you have seen Python, especially like the Python that you see, for example, in Grasshopper, looks nothing like this. This is way more like complicated in terms of syntax, but it's basically the way that you're supposed to input the information. So here, this is the important part. We'll say like g.run. So the generator actually generates something. We will pass c, that is the vector, a label, and also we will pass those arguments. So this will be like g kw args. Basically, this will these are a batch, height, width, and channel. I don't want to. I will give you more information later. We just want to generate the image from that. So now we want to we are not passing the label. So let me, in case we want to, let me think for a second. Do I want to go here? I want to go here. Because we'll have two generate image functions then. Let me think for a second, just a second, what we're doing here. GC. I'm checking my notes to see how can I save some time so we don't extend too much. Yeah, let's just leave this generate image like this. Let's code a couple of things. If we get an error, we can come back to this. So now we want to code a couple of more things. So let me see. Exercise. Yeah, let's put one. Sorry, not here. We will create another definition that is called expand. I will put, basically I'm trying to cut some code from my notes so we can gain time, but I will put the full code available in the video, and also like I will send you the image in a Dropbox folder that I will share with you, including yesterday's code. So expand seeds, basically this will take the seeds, also a vector size. We will create an empty list with the result. So basically this will be a list with the result. So we will say like for seed. Basically this will work with when we input, because we will input like a range of numbers. So this will take each of the numbers and create the information that we need to input to generate not only one image but many. So we will say like for seeds, can create a random, then we can say that random state, and here we can input the seed. So basically this will, if we input like many numbers, this will take each number at a time and generate new information for that. And the result, we'll put the result from that random number, result that append R&D that rand n one and vector size. Then we will return that result. It's another helper function that doesn't make any sense right now, but that's fine. Now, we can do a couple of things. So I want to, if we want to check, for example, the type of images that we're generating, we will do a couple of more things. But we will do those here, like to check, for example, like what type info we are. And for that, we will write a small code here. We will specify a URL. Here we will use a URL, and we will probably use the same model that we use here. So I will just copy this path here. And I will say device torch.device. And with this, basically, we're telling a Colab to use, sorry, this is CUDA. We're forcing Colab to use CUDA device, the CUDA device, the GPU, to generate the information that we want. If we don't do this, we might get like no CUDA devices available. So we will get like an error, like no CPU is capable of producing the images that we want. Because of the things the reasons that I explained yesterday in the difference of cores and so on and so forth. So with pnn live that util that open URL. This is what I should have done before when we tested the thing. So basically, this takes a URL, basically an address. That could be also like an online file. Actually, I can test with the previous one. This is a URL. This is a path. As f, this is an alias. We will say like our generator G is equal to legacy that load network PKL. So basically, this is taking that Pickle file and loading it. And here, basically, as f, we're using f as an alias, as a file. So we pass that argument here. With that file, we will say gema. That is the part of that file that we want to use. .to device. So what does this line mean? So basically, we're creating our generator using this instruction, load network. We're passing that file, and that file is basically like opening. That file is created by opening a URL, right? And then it's just loading one specific part of that file, but it's loading that network, that architecture into our GPU. So that's something like really nice about pytorch, that you can specify load this into the GPU, or GPU 1 or GPU 2 if you have multiple GPUs. In this case, this is loading that into the GPU because our device is the CUDA device. And now we can say something like vector size. We can say here g.c dimension. So it will take the dimension of the vectors that are in this model, right? And so here we can say like seats, and we can call that expand seats function. So this will expand seats. Again, this is just to see if this is working. So let me pass here some arguments. So for example, here I can say like 8192 and 8192. Actually, I'm going to do it this way: +1 +9. This is kind of stupid, but let's test it like this. So basically, it will give us a range between 8,193 and 8,201. And the vector size. This is and the vector size. And now I'm going to print seats 0 shape. See if it actually does something. So let me just execute this. Hopefully I won't get like an error. Invalid syntax, of course, because I forgot to put the colon here. No errors in the definitions here on the syntax. If I run this, it should start loading our model. Yeah. So now we know that this is giving us like dimensions. So let me just change this. This is working. It's not giving us errors. So we should be ready to actually create stuff with this. Yeah. So let me see here if I change this. Yeah. That's good. It should create like images of a specific dimension. That's fine. Now, let's say we want to get a bunch of images and display those images. So to display images, now that we have this, this could be like the step 5. Step 5 is actually like create and visualize images. And this is a step that is very important because basically this will help us to sample some vectors, and from those vectors we will use those to actually generate a full interpolation of those vectors. So let's do this. Probably we won't have time to do the training part, but in the third part that I will record offline after this, I will give you the tool to actually train over the weekend the things that you want to train. So don't. So basically, I want to show you this because you will use everything that we're coding here with your own data. But training the data is like actually so easy that it's ridiculous. And you will understand why everybody's jumping into this bandwagon of using GANs, because it's easy to implement. So to create and visualize our data, so basically to navigate in a more like to navigate the latent space, but also like to visualize the results so we can pick interesting images like in a more interactive way, let's say, we will do something like seed from, for example, like a starting number. We won't do this like that I did here. So basically we will code this as parameters. So let's say we want to start with the seed from 100 and seed 2 equals to from our initial to get like an initial vector and a final vector. Let's generate, I don't know, 100 images. That will take a while, but that's fine. And here now we generate images from the seed range. Basically, we'll say like for I in range. Let me put this a little bit bigger for I in range. And that range will be seed from. So basically, it will generate the I that is our iterator will go from 100 to 200. Oh, sorry, it's seed 2. Print, we will print some information to see that this is working. F quote seed I. So this will show like the current seed number that we are generating, and we will say like our seed vector. So basically here we will generate now the vector, and for that we will use this function that we created here. So basically that number will be converted in a vector, and we will print that in order to see what we're generating. Seed to vec, and we input first the generator. The generator, we have it here. We just created this. So remember to execute this before you execute this, because we will need the generator, and we need the number. So basically this will take, for example, 100, and it will pass that number to the generator to generate like this new vector. So this converts seed number to a vector. So just for debugging purposes, we will print seed. And now what we want to do is actually to generate the image. To generate the image, we will say like img equals to generate image, and we will pass the device that in this case is CUDA. We will pass the generator, and we will pass the vector. And then we will use, of course, our function that displays the images, the image, and that image is img. So this will generate a lot of garbage probably because of this. So actually I will do something. I will do it with just one image just to test what the results are. Sorry, I had like a wrong indentation. So let me fix this. Okay. Now it should work. It's giving me GZD is not defined. So it's giving me an error in one of the functions. Let me check one thing. Yeah, I never. Oh, sorry, I'm missing. I have a typo here. It was a point like g.c_dimension. So let me just. Every time you make a modification to the code, for example, if you have a typo, you just like run it again. And now if I run this again, it should work. Yeah, it gave me one error, but you see what we I mean, now this is printing like the number 100 produces this type of information. But I have an error here. Let me take care of that error. TF-lib is not defined. Why? Am I missing something? Just 1 second. Oh, actually, I'm so stupid. I did something completely stupid. I realized that I opened my other implementation in TensorFlow, so my generate image was completely off. So forget about this. I mean, we will generate like an override for this. I will just comment this. This is super stupid what I did. This is the function that I want to generate. So I don't want to close it again. If you paste this, now I commented this function. Actually, this is the one that we need. That one that takes like pytorch. Sorry, this is an override to this. It's called generate image. It takes the device, the generator, the vector. It gives you the truncation that is 1.0. It has like constant noise mode to add like some noise to the thing, and we're not passing any class. So here basically it's passing that vector to the device. Basically, it's like taking that is a NumPy array. That information that you're seeing here, this is a NumPy array, and it's taking that NumPy array and it's passing that information to the CUDA device, and then we're getting something that is called like a label. And for that, actually, yeah, there are a couple of things that I need to pass as well. So also, I'm giving you this code because I am stupid. I was doing something. I don't know why. I was like, maybe I'm too tired. There's another definition here that we're calling that is called get label. That takes the generator, takes the device, and if you pass, for example, like a class, you will generate that label that we will use here to generate an image, and that image will be generated here, basically taking that information from the vector to generate that image that is actually being generated. Basically, that is the image that is like an array of data that we use PIL, Python image library, to create an image from that array, that an RGB image. So let me see if this works. I pasted that data. It didn't give me any error. So hopefully now this will generate the images. Yeah. Sorry for that. I don't know why I just got confused by it. Like it was, I'm just checking my notes and I was like doing that method to generate something with TensorFlow. This is why it was giving me the error. So now I will comment this because we don't need like this amount of numbers. So just let me comment this guy here. And let's say we want to generate, because you saw that the image generation is like quite fast. I will generate 50 images now. So when you do this, you will see that it doesn't necessarily like creates a perfect transition from, let's say, image 100 to image 101, because we're generating, basically we're from that number, we're generating random data to generate an image. The interesting thing is that, let's say we want to create that interpolation that I talked or that I mentioned before. For example, I said like this is visually like interesting, like this image 101, right? This image 101, and actually let me do one more thing. Let me see if I can load that model that I shared with you, that address that I wanted to use before. Just 1 second. Let me see if I can use the NVIDIA models here. Let me see if I can use any of these models here. Pre-train, copy link address, and change the URL. So maybe we can have another sample, not like something too abstract like this Gary or Saha-like images. So I will select URL. Is this? Yeah, this is downloading. So now if you replace like I gave you this link. If you click and copy link address, you can download the model, like a new model. In this case, it's like the trained model from NVIDIA, and I will generate images with that. So now this is, you see, it's generating all faces, not buildings. It's as simple as that. So what I'm showing you this because I'm using now. I gave you one of my trained models, but you can also like download models. Like there are pages that have repositories of models trained on like a lot of things, and probably people that have money, they have like NVIDIA 3090s that have been, I don't know, like training models for weeks to generate something specific that could be interesting for you. So if you don't have the means or the time to train something, you can always use models from other people. So these are interesting, like old faces. So let's say we want to generate a transition from this dude here, Sid. Okay, the number on top is the one that corresponds to the other one. So let's say we want to transition from seed 108 to seed 112. So we can annotate those numbers, 108 to 112, and we will generate a transition to create like all the things in between. So this is why I said that this is interesting, because you are able now to generate those transitions. So I will show you how to do that. This is the last part. Sorry, I know I'm a little late. I will take some time. So now I will show you, and this will be complemented with the third part that I will record offline, how to use this information, for example, to create something in Grasshopper. It will be quite interesting. I will post this, for me, it's like 1 p.m., probably like around my 9 p.m. I will have this ready and available on YouTube with the link to the repositories and the code from yesterday and today. So you can try over the weekend, so we can meet on Monday. So now let me code this quick. We can create a video interpolation from different vectors. And to do that, actually, we can call this step 6. We will create the code. So we want to have something that is called seeds. And here, this is an array that we can put directly. So we said that we wanted to create a transition from seed 108 to 112. let's add another one, like to 117, for example. 117. We can specify, for example, the number of steps. So basically the number of images between one vector and the other. Let's say create 100 steps. And here we'll select from TQDM, that notebook, import TQDM and TQ. And here we will select os.make years. This is, for example, a way of not specifying a preset directory. Here we will create a directory, a folder that is called, for example, like results. So we will say like create a directory that is called results. And exists. Okay, in case if exists. If it exists, like it will just use that for our results. So here we will generate the interpolation. How does this work? We will declare like a counter. So we will start with an IDX, like it's like the index. It will be 0. And we will say the following thing. For I in range, len seats. Basically for the amount of seats that we have, -1. So that means that it will start, let's say now we have 3 seats. So basically it will generate like 3 loops, 3 cycles, because we have like, 3 numbers. Actually, it will generate 2 because it's the number of seats, the number that we specify here, less 1. Because we need to create basically 2 transitions. That's the meaning of this. And we will start with the origin vector. We will get the origin vector. And to get the origin vector, we will say B1 equals to seed to back. Remember, this transforms a number into a vector. And to do that, we pass the generator. And seeds, we will pass seeds and the index I. So basically this will, when I is 0, the starting number, it will look this number and it will pass it here. Now we need to calculate or get our destination vector. And that destination vector will be called, I have a point here that's not supposed to be here. Destination vector will be B2 equal to seed to back. Again, we pass the generator and seeds, in this case, will be I plus 1. Meaning that it will get the second number. And then for the next cycle, the next loop, this will be I, because this is the first number, and this will be I plus 1. So we will have our 2, let's say like the domain, the 2 domains, the origin and the origin and the destination. And now we want to perform vector arithmetic. As simple as that. And that vector arithmetic is basically just subtracting, getting the difference between one vector and the other. So we will say like diff equals to b1, b2 minus b1. So basically we will get like one list and subtract the other one. Remember this list, this numpy array with a lot of numbers, we will just subtract one number to the other. And now we can say like steps is equal to that difference. I don't know why this is giving always a point. That it will be equal to that difference divided by steps. And steps with uppercase steps. And this is step. And now we can say like current, we want to have a current, let's say, result from that arithmetic operation. We can say like v1 that copy. We'll create a copy of the first vector. And now we do some we do another loop for j in tqdm range steps, comma desk. This is f seed. This is just like string formatting, so to show what is the progress of our model. 2 points, and here we will say the following thing. Like the current vector is equal to current. So current is equal to current plus step. So what we're doing here is like to the current vector that we have right now, that is the copy of the origin vector. We will add that vector, those values divided by, in this case, like the number of steps, 100. And then that step vector will be different because so basically each time we will add like a little bit of portion of the other vector. So we will have something that is like, it will generate this slow transition. So now we have current will be current plus step. And now with that information, we can generate an image. And this will be like generate image. Remember that we need to pass the device, the generator, and current, basically the current vector. And we will do 2 things here. We will generate the video, but also we will generate all the images. So we can use that, for example, in another software. To do that, we will do like image, save, and we will pass here a path. So we can say like save those in results, and we can give a name, frame, because we will generate like some sort of like video, and this will be I and IDX, sorry, IDX, the index that we're generating, the counter, and we will generate a PNG image. And we will say also image that's saved. I will create another directory here. I will do it manually, and this will be interpolation. Where is it? Interpolation temp. I will copy the path, and I will say like img save. In this case, I will give this path. And I will say that this is frame. Basically the same thing here. So I will save the images like in a temporary folder, but also I will save this in a permanent folder in my Colab, and sorry, in my Google Drive. The next thing that we need to do is set IDX plus equal 1. So after each cycle, the index, sorry, is plus equal. After each iteration here of this, after you save one image, this will 0 will increase its value by 1, so you can change the basically the number, sorry, the frame name. And if we want to create a video with this, so this is the last part of today's tutorial, it will be, we can use ffmpeg minus r. Basically, this is the frame rate, 30 frames per second. And we will say like minus I, the origin. So for this, we can say the following thing. We will say like results slash frame slash $D that PNG. So basically, this will take all the names that start with frame and finish with PNG. Some parameters for the encoding of the video, be codec. We want this as MPEG-4 format -I, and we will give the name interpolation.mp4. All right, if I didn't get like any typo, this will generate the actual interpolation. So I hope, of course, I had make tears. What did I do wrong here? Exist. Okay. Oh, sorry. I always put an S. Exist. Okay. Now I have another step. Steps is not defined, of course, because this is uppercase steps. Now it's working. So now you see that this is actually like generating all the interpolation. We use TQDM to actually show the progress. So let me see if this is actually, yeah. So you see, this is already generating our frames. So if you go to frame 0, it will generate this lady. Frame 1, it should generate the lady, but a little bit changed. So basically what we will do, we will transition from this lady, the face of this lady, to the one guy, and then to another guy. And I know this has nothing to do with design or architecture, but I'm just showing you the tool to actually make this, because we will use this information to do something with Grasshopper, but I will teach you that next. While this generates the video, I will briefly show you the training part. But to show you the training part, I also need to show you a couple of other things. So that's why I'm leaving this for the initial additional bonus video that I will record after this, so I don't keep you like online. What I will teach you that the code to actually train this model is actually ridiculously easy. So this is what I will give you. We want to check if we have GPU. We want to configure our notebook with probably like a standard to high RAM according to the amount of data that we're using. We will mount our Google Drive. We will try to see if this is actually working well with Google Colab. We will access, for example, a content with images that we want to train. And that's what I'm going to show you. We will use a tool to get images from Flickr. That is a little bit longer to do that, but this will automate the process of, for example, like getting images, or you can use images that you take. You can take pictures, put them in a Google Drive folder, and check that content like with this line. We will clone a StyleGan2 ADA, and we will use basically a tool from StyleGan2 to format our images and create a data set, and then just use like this ridiculous line of code to train our network. And I will teach you how to resume the training. But for that, I need to teach you a couple of more things. So Google Colab, for example, doesn't have, I mean, it has like a mechanism that, I mean, training will take hours, if not days, right? Even with Colab. If you don't move your mouse, for example, or if you don't click on the Colab for a couple of hours, they will kick you out. With Google Colab Pro, it doesn't happen, but you will have 12 hours of training. Right? That's enough to generate at least a couple of like PKL files with some preliminary results. But I will teach you how to avoid Google Colab to kick you out. And that will be in the third part of this video. So this is almost finishing the other transition. Probably there are a lot of questions. Please write me an email, but write me an email not to the Digital Futures email. I will leave that to only send you the invitations and stuff like that. I will give you this is my email, my personal email at MIT. This is the one that I have configured in my phone or in my laptop, so I can respond like quickly. So send me emails like that from there. Let me see if this created a video so we can finish today's session. So here we have interpolation.mp4. I am downloading the video, saving this, and let's open and let's see the magic. Ooh, perfect transition between one and the other. So if you try with your models, basically, you can do interesting stuff that I will show you how to do and use, for example, this information inside Grasshopper to create like interesting things with GANs and 3D data, right? So that will be your assignment to play with these things. I will, again, I will give you all the code and something extra so you can play with this, generate some things we can discuss, and we will move to something a little bit more elaborate for the last session that we have on Monday, 10:30. I'm going to leave it to here because I need to go, but if you have questions, please write to me. If you have problems implementing this after I send you the code, also please let me know. And the videos will be available in YouTube soon. Julie is very excited. Did you like it, Julie, to see this?
I had all caps on by accident, but yes, very excited.
Okay. Awesome. That's the idea for a brief workshop like this. All right. I will see you on Monday, and wait for my email with the information about this and yesterday's code. So take care. See you.
Thank you.